In this video, we want to learn how we can use the conjugate method for finding limit of sequences. The first example is n minus s square root of n to the 2 plus 4n. Immediately, when we see we have a difference here between two expressions and one of these expressions have a radical, we know that probably we can use the conjugate method for finding limit of this sequence. So we want to find limit of n approaches infinity. You know that in the sequences always n approaches infinity. We want to find limit of n minus s square root of n to the 2 plus 4n. First of all, note that this limit is in the form of infinity minus infinity because n approaches infinity. So the n is infinity minus this radical is also infinity because n approaches infinity and this radical approaches infinity. So we have infinity minus infinity. And we know that infinity minus infinity is an indeterminate form in the limits. So by substitution we cannot find anything. So we have to use the conjugate method. For finding this limit, we multiply the numerator and denominator of this expression by the conjugate of the bracket, which is this. N plus s square root of n to the 2 plus 4n. So we multiply numerator by the conjugate, and also we have to multiply the denominator by the conjugate. And attention, you can consider a 1 for the denominator of this expression. So we can consider a 1 as a denominator for this expression given here. Now by multiplying the numerator and denominator by the conjugate, we can get rid of the radical here. In numerator, we have n to the 2 minus n to the 2 plus 4n. What happened from here by multiplying these two to here? Let me explain to you. Remember this identity. A minus b times a plus b is always a to the 2 minus b to the 2. This n plays the role of a and this radical plays the role of b. When we multiply a minus b by a plus b, the answer is a to the 2. So the answer is n to the 2. As you can see here, this is a. And when we multiply by the conjugate, the answer is a to the 2. So n to the 2 minus, don't forget to put the minus here, minus b to the 2. What is b? B is this radical. But we know that when we raise a radical to the power of 2, the power of 2 with radical cancels and only the expression inside the radical remains. What about denominator? We multiply 1 by this expression, so we have only this expression in the denominator, n plus radical n to the 2 plus 4n. Now if we simplify the numerator of this fraction here, we have negative 4n. So by simplifying numerator of this fraction, we have negative 4n in the numerator. Because n to the 2 minus n to the 2, they cancel each other. And this negative is for all of this. So we multiply this negative by 4n and we have negative 4n in the numerator. What about the denominator? In the denominator we have n plus radical n to the 2 plus 4n. Now for finding the limit of this expression here, I will show you two different methods. One method is a little easier and faster, which you can use. In this method, we only consider the terms that are significant in the numerator and denominator. In numerator we have only negative 4n, so we keep negative 4n in numerator. When we look at the denominator, we notice that we have n, so n plus, now please attention to this part, we have n to the 2 and 4n. Between these two terms, which one is significant? Which term in the radical we have to keep? And which one we can ignore? Between 4n and n to the 2, of course n to the 2 is bigger term, is more significant because n approaches infinity and n to the 2 is bigger term, is significantly bigger, infinitely times bigger than 4n. So here we ignore this term. If we ignore this term, we have a radical n to the 2. What is s square root of n to the 2? It is n. So in the denominator we have n plus n. So we have negative 4n. Divide by 2n, and the answer is negative 2. So as you can see, this method is very short and very effective. We can simply find these limits. So let me review the method with you again. We look at the numerator and we look at the denominator, and we only keep the significant terms, the terms that have the highest degree in numerator and denominator. In numerator here we have only one term, so we write that term. When we look at the denominator, we notice that we have n, so we keep n. And inside the radical we have two terms. Between these two terms, n to the 2 is the dominant term, so we ignore this term because it's basically like nothing compared to the n to the 2. Only we keep n to the 2, but it is in the radical. And radical n to the 2 is n. n plus n is 2n. So we have negative 4n over 2n, and it equals negative 2. So this is very effective and fast method. But let me show you the other method that you can find in most of the textbooks. And this is the more mathematical way for finding this limit. If you remember, for finding limits that are in the form of a rational expression, this is not a really rational expression, but it's like a rational expression. The method is to divide numerator and denominator by highest degree of denominator. What is the highest degree of denominator? The highest degree of denominator is n to the 1. Please attention. We have n to the 1 here. Maybe we think we have n to the 2, but here, no, it's not n to the 2. This is in the radical. When we have a radical n to the 2, it is like n. So, the highest degree, the term with highest degree in denominator is n to the 1. So, we have to divide numerator and denominator by highest degree of denominator, which is n to the 1. So, for finding this limit, we divide numerator and denominator, every term of the numerator and every term of the denominator by n to the 1, or basically n. So then we have negative 4n divided by n. In the denominator we have n divided by n plus radical n to the 2 plus 4n divided by n. In numerator simply we have negative 4. In denominator we have 1 plus. Now look at this part, which is a little difficult to simplify. We want to simplify radical n to the 2 plus 4n over n. For simplifying this, let me write this expression here. We have radical n to the 2 plus 4n divided by n. To simplify this, attention that we can write n, which is in the denominator, in the form of radical n to the 2. Radical n to the 2 and n are the same. Why I am doing this? Because I want to have radical in numerator and have radical in the denominator, and now I want to combine these two radicals. So, for simplifying this expression, first we rewrite this denominator in the form of radical n to the 2. Now, we combine the radical of the numerator with the radical of the denominator. So basically we have n to the 2 plus 4n all over n to the 2. Because both of them have a radical, we can combine them and write this expression in the form of one radical. Now let's simplify the expression that is in the radical. If you attention, we can write this as n to the 2 over n to the 2 is 1. And then we have plus 4n over n to the 2, which you can write this in the form of 4 over n, because 1n with 1n cancels, and at the end we have just 4 over n. So we can write this expression in the form of radical 1 plus 4 over n. Now, what is limit of 4 over n when n approaches infinity? When n approaches infinity, 4 over infinity, numerator is a number, denominator approaches infinity, so this fraction approaches 0. So basically this is 0. The limit of this is 0. So we have negative 4 over 1 plus radical 1. Again, this is 0. So we have radical 1. Radical 1 is 1. 1 plus 1. Negative 4 over 2 is negative 2. So the limit is negative 2. And if you remember, from the previous method, we did the same thing and the answer was the same. But of course, that method was easier and faster. But this is the method that most of the textbooks use for finding limits in this form. Look at this example. an is given s square root of n times s square root of n plus 6 minus n. Again, it is clear that probably we need to use conjugate method for finding limit of this sequence. So we want to find limit of n approaches infinity, radical n times radical n plus 6 minus n. Before doing anything, first I prefer to combine these two radicals and write them as a single radical. So basically we can write this in the form of limit n approaches infinity, radical n to the 2 plus 6n. If you multiply n by n, we have n to the 2, n times 6 is 6n, minus n. This limit, as you can see, is infinity minus infinity. And when we have infinity minus infinity, this is indeterminate form, and we have to find a way for finding this indeterminate form limit. And of course, here we have to use the conjugate method because we have a radical, and to get rid of the radical, we have to multiply the expression by its conjugate. So we multiply numerator and denominator by the conjugate, which is this. By multiplying the conjugate, we have in numerator n to the 2 plus 6n minus n to the 2. And in denominator, we have radical n to the 2 plus 6n plus n. If you simplify numerator, you have only 6n, and in denominator, we have radical n to the 2 plus 6n plus n. And n approaches infinity. Again, for finding this limit, you have two choices. You can find this limit in two different methods. One way is to just keep the dominant term of the numerator and the dominant term of the denominator. In numerator, we have only one term, 6n. In denominator, what is the dominant term here? Radical n to the 2. We ignore this and we just keep this, and radical n to the 2 is n. n plus n is 2n, 6n over 2n, this is 2n. 6n over 2n would be 3. So this limit is 3 based on this shortcut method. But let me show you the other method, which is harder, but it's good to know. We divide numerator and denominator by highest degree of denominator. Again, it is n, so we have limit n approaches infinity, 6n over n, radical n to the 2 plus 6n all over n plus n over n. Numerator is only 6. In denominator, if we write this in the form of radical, we have radical n to the 2 plus 6n all over radical n to the 2 plus 1. Now let me show you again how we can simplify this. If we combine these two radicals, we have radical n to the 2 plus 6n over n to the 2. We can write this in the form of radical 1 plus 6 over n. So we can erase this and replace it with radical 1 plus 6 over n. n approaches infinity, so this fraction is 0. So in denominator we have 6 over radical 1, which is 1 plus 1, and it equals 3. So the limit is 3. Now look at this example. What is the limit of the sequence 1 over s square root of n to the 2 plus n minus s square root of n to the 2 minus 1? It should be clear that for finding limit of this sequence, probably we are going to use the conjugate method. But before that, what is this limit? If n approaches infinity, this is infinity, and basically we have 1 over infinity minus infinity, which is indeterminate form. So for finding the limit of this sequence, we use the conjugate method. We want to find limit n approaches infinity of 1 over radical n to the 2 plus n minus radical n to the 2 minus 1. And for finding this limit, we multiply numerator and denominator by the conjugate, which is radical n to the 2 plus n plus radical n to the 2 minus 1 over same expression. By doing this, what we have in the denominator? In the denominator, because we multiply this by its conjugate, the radicals cancels. And we have only the expressions inside the radical. From the first radical, we have what? We have n to the 2 plus n. From the other radical, don't forget this negative. This is important to put the negative, then put bracket n to the 2 minus 1. For numerator, 1 times this would be this expression. So we have a radical n to the 2 plus n plus a radical n to the 2 minus 1. If you look at the denominator, in denominator we have n plus 1. N minus minus 1 is n plus 1. And n2 minus n2, they cancel each other. In numerator we have radical n to the 2 plus n plus radical n to the 2 minus 1. Now, we have a fraction. We can define this limit again with two methods. Let me show you first the fast method, the shortcut method that you can use. Keep the dominant term in the bottom and then the top. In the bottom, we have n plus 1. Which one is significant? N, of course. Because n approaches infinity, but 1 is a constant, is a number. Compared to infinity, is nothing. In this radical, we have two terms. N to the 2 is significant, radical n to the 2 is n. From the other radical, it's also radical n to the 2 is important. N plus n is 2n, 2n over n is 2. So with the fast method, as you can see, you can find this limit easily. And the answer of the limit is 2. But if we want to show our work, we divide again the numerator and denominator by highest degree of denominator. In the denominator we have n to the 1, so we divide every term by n, n over n plus 1 over n. In numerator, radical n to the 2 plus n all over n plus radical n to the 2 minus 1 over n. If we simplify denominator, we have 1 plus 1 over n. What about numerator? Again, similar to the previous questions, we have to write this n as a radical n to the 2, and then we combine the radical in the top with the radical in the bottom. Let me show you. Radical n to the 2 plus n over n. Instead of writing n, we write radical n to the 2. So instead of this n, we write radical n to the 2 because they are the same. Now we combine these two radicals, and then we have radical 1 plus, what happened? n2 over n2 is 1. n over n2 is 1 over n. If you want, you can write all your steps. You can first write n to the 2 plus n all over n to the 2, and then you can write 1 plus 1 over n. So in numerator, now based on this, I can write a radical 1 plus 1 over n. And for the other radical, in a similar way, you can see that it equals to 1 minus 1 over n to the 2. Let me show you why. Here we have n to the 2 minus 1, so I have to change this from plus n to minus 1. Then here also we have minus 1. N to the 2 over n to the 2 is 1. Then we have minus 1 over n to the 2 as this. So we have minus 1 over n to the 2. Now, n approaches infinity. And we know that when n approaches infinity, any number over infinity approaches 0. The limit of that expression is 0. So this equals to, this is 0. This is also 0. They approach 0. Their limit is 0. So we have radical 1 plus radical 1 over 1. And it equals 2. I hope by watching this video you have learned how to use the conjugate method for finding limit of sequences. If you like this video, please subscribe in my channel and see you in the next videos.